Hi everyone. Today we're going to kind of skim through very quickly in the prerequisite chapters. We're going to go through sections 1 through 5. I do have my textbook here. Yours is located on WebAssign. It is in the front page if you scroll down to the bottom on the right hand side. So if you're looking through this prerequisite chapter, it will look very similar to this. So I will point out some things and I will make notes as needed too, so some of the things that you kind of have to remember. This again, the prerequisite chapter should be review for you. If it is not a review, so if you've never seen this material before, you have no idea what they're talking about, please send me an email and let's talk. I don't want anyone to struggle completely through this class, and I'd rather you get into the class that you need to be in than trying desperately to work through this one. Again, this prerequisite chapter and the chapter 1 should be review. There may be some topics you can't remember, and that's okay. But if this is stuff you've never seen before, please email me so we can get you where you need to be. Okay, with that being said, the very first section is about modeling, and what I want you to be able to do in your modeling is if you have a formula and it says to find P for given values, you know that how to substitute values and then walk through the correct order of operations to get that. We will be using calculators, so I'm expecting you to be able to use your calculators relatively efficiently. There will be times that I will try to remind you on things so that you can bring those back into play. So it starts off with just kind of going through some examples on that, on your modeling. So just looking at all of those sorts of things. P2 is all about real numbers. So kind of remind you, the natural numbers are, the counting numbers. Sometimes we refer to the natural numbers as the counting numbers. Integers are both positives and negatives, and including the zero, so the numbers we usually put on our number line. A rational number is a number that we can write as a fraction. And then we also have irrational numbers. So you should be able to kind of identify what your rational numbers are, what your irrational numbers are, and so forth. So just kind of remind yourself of those things. So in the second section, we talk about real numbers, positives, negatives, and things of that nature. So kind of make sure you go through that. Also, we remind ourselves of some of the properties that we have, and this is some of the things you may be a little rusty on, and I've got to get rid of the glare. Let's turn the light off and see if that helps. Ooh, that's too dark. Sorry, we'll see if I can zoom in. Maybe that'll... It's a glossy paper. There we go. I'll just kind of lift the page up a little bit. Okay, so here we have, our cumulative property. And what I'm also going to be doing in this course, because a lot of times you have seen some of the material we talk about, is I'm going to start making some of the connections as to, yeah, we have a cumulative property, that we can add A plus B. So we could add two things and we could switch their order and it doesn't matter. Okay, we can do the same with multiplication. Associative, we can regroup things. Distributive, we can distribute over that multiplication. So we have these properties and we've been using them, and you've been spending time saying, yep, they're there, but it's a lot of times you don't get the big picture. So I'm going to be trying to make those connections to the bigger picture. This cumulative property, why are we able to do certain things that we do? Well, it's because of this cumulative property. So here we have those properties, so kind of remind yourself of those. We also have properties of negatives. So looking at negatives, if you have a negative times a value, it's the opposite of that. The opposite of an opposite, they kind of undo each other. Where we write that negative does not matter. If we take a negative times a negative, it's a positive. You can distribute the negative in, so kind of working with our negative values. And where we can sometimes see that is being able to distribute this over an expression. So we distribute it to both parts, making sure we do that. We can distribute it over 3 things, and then we can kind of combine a negative is a positive. So kind of reminding ourselves of all those little properties that we've done and used. We also have properties of fractions. So how to multiply fractions, how we divide fractions by inverting and multiplying, how we add fractions with a common denominator, how we add fractions or can add fractions with different denominators. We could just take the multiple of those 2 things to get our common denominator. We do know that there is sometimes a more efficient way, especially if there's a smaller value than just the multiple of those 2. If we have a common factor in a fraction, we can reduce it. So there's a C hiding in both. So looking at like 10 over 15, we can reduce by that 5. And then if we have 2 fractions that are equal to each other, we can cross multiply. That's working with proportions. And then we can solve from there. So hopefully these are things you've been doing. Again, as we practice, we're going to try to bring back and get those rust kinks all oiled out again. We have touched on the number line, so you should be familiar with a number line. You should be able to place certain values, like where is the square root of 2? Well, you could use your calculator to get the decimal for the square root of 2, and you would know that it's going to be between 1 and 2. Negative pi would be a negative 3.14. So knowing where some of these things are located. Some notational things. This one we will work with as we go, so just kind of read through these, and I will kind of be enlightening you on some of those things, because it's also my job in this course is to start have us being able to read more mathematically. You can read a novel, you can read a history book, but reading mathematical is a little different because we use a lot of times symbols to represent words. We have a set. So our set is just a group of stuff, a group of things. Elements are those things. And then we see this funny looking E. That just means an element of. So this is telling me that A, whatever A happens to be, is an element of S. So that means A is contained in S. So if I had the things that S contained listed out, A would be one of them. This is telling me that B is not an element of S. So that means if I had S all listed out, the letter B would not be in there. So then we kind of go into some notation of how we can do that. So here is a set. We called it A. We could have called it B. We could have called it Cuba. We could have called it anything we wanted to. And it contains the elements 1, 2, 3, 4, 5, and 6. So we could list them like we did here. We can also write them using what we call set builder notation. And that looks like this funny looking stuff. So again, it's A, the name of our set is, and it's going to be the set of all x's. So x is just a generic variable. The straight up and down line is read as the word such that. The set of all x's such that x is an integer and it's between 0 and 7. Yes, you could have written it as x is an integer and 1 is less than or equal to x, which is less than or equal to 6. So had some including inequalities there as well. So there's lots of ways to write sets. I want to also remind you on graphing. using number lines. So if we are talking about, oops, there we go, an interval from A to B, not including those points, we have two ways we can represent it. This is three. This is the set builder notation, the set of all x's such that x is between A and B, not including. If you drew that on a number line, we like to use the little open dots. Some of you might be have learned the round brackets and square brackets. Those are used as well. Or we use what we call is interval notation. So this represents not a point, but the interval from A to B, not including those endpoints. This would be the interval of all the numbers from A to B, including both of them. So it kind of goes through all the different possibilities. We will be using this interval notation quite a bit. We tend to not use the graphical notation simply because we're trying to get a little bit more sophisticated and we want to be able to write things in a more mathematical feel, and these are the ways that we're going to be doing it more often, using this set builder notation and the interval notation. Okay, so kind of walk through those things. You should be familiar with the absolute value function. Being able to calculate what the absolute value of -7 is. So kind of walk through that. And let's see, then we get into the third unit. And this one you might need to spend a little bit more time on. This is how to simplify some expressions with exponents. So I know you have seen it, but again, it might just be a little rusty. So go back, double check how to do those. Here's going back a page. All those laws, when you have something to a power, another one to a power, we can add those exponents. How we subtract if you're dividing, raising a power to a power. All of those properties, again, we should remember these from before. They go back way back to an elementary algebra class, which you may have had in high school, or it might have just been last year. I don't know where you're at. So make sure you go back and remember them. We will be using them. And when they come up, I'm not going to spend a lot of time reminding you of all those properties. So refresh yourself of those things. Scientific notation we won't spend too much time on unless we're working in a word problem that we'll see it. So if you come across one, you'll just need to remember what it is, how it works, scientific notation. It is a way to write really large numbers and really small numbers. So that kind of took us through number 3. P4 is about our rational exponents, so square roots, cube roots, and things of that nature. So kind of, again, refresh yourself on those roots. Remembering how to go from, let me see if I can remember. There we go. This is what I'm looking for. Like the square root is that half power. Cube root would be that 1/3 power. And fourth root is at 1/4 power. Again, we'll remind ourselves when we see them, but just kind of remember how all the properties go. Again, you've seen all these, so kind of look through some of the examples, go through some of those more in detail. Again, my lecture right now is very quick and very, I'm skimming. This is what I mean by skimming. We talk about rationalizing a denominator. I will remind us how to do so when we need it. There will be times when we want to rationalize the denominator. I'll also remind us why we do it, because some people say, well, why do we have to? Calculators will do it for us. So I'll give you a little historical note as we start working in it more often. So, and I might do a follow-up video and come back to that, because that is kind of a fun topic to remind students of as to why or how we rationalize our denominators. So after the skim, I'll put in another video which is a little bit more in detail. All right, the last one in this section is P5, which is on our algebraic expressions. In other words, we have polynomials. We will spend lots and lots of time with polynomials, so just kind of do a real brief overview of this, and we will, like I said, we will actually hit on this again. So yeah, I don't know how much of this you need to kind of remind yourself on how to do. I will ask, though, that you kind of spend a little bit of time, some of your special products, remembering how to foil, things of that nature, and also maybe going back and how to factor, but actually that's in section 6. So section 5 is just mostly the foiling, multiplying things out, and adding like terms, distributing, and all of that sort of stuff. So I'm going to stop here for now, and then I'm going to make another video for these first 5 sections on just a few of the bigger ones. For example, I want to do one simplifying with some exponents, because I know students sometimes forget those, and I also want to rationalize those denominators, just to make sure that we all have that in play. So I'm going to stop this video, and I will create a new one with those 2 topics. So please come back and watch that one as well.